right. Get some fresh page here. Thank you, Jerica. Appreciate it, guys. All right. Let's try and make this a little cuter. Okay, so this was the chapter 5 quiz problem. Was that problem 4? Is that right? I'll check.
Yeah, it was problem 4.
Okay. So there were some different variations on this problem, so I'm just going to do one. If it wasn't the one that you guys did, I apologize. Okay, so we were looking at the formation of carbon dioxide gas. Does anybody know what this reaction represents? It's one of my favorites, but I can't take part in it because I'm pregnant. Nobody? No?
Oh, okay.
Fermentation, right?
Yeah.
So this is taking sugars, right, and breaking them up into alcohol and carbon dioxide, right? So this fermentation process is what happens when yeasts are eating up sugars in barley, and that's what makes delicious beers. So, trivia, not important, but there it is. So we're looking at the volume of carbon dioxide gas collected when we have 48.25 grams of a 25.0% by mass solution of glucose, which is this guy. And then we're given some other information about the temperature, 26.5 degrees Celsius. The total pressure is given as 792.33 torr. Oops. And the partial pressure of water at this temperature, yes, is 25.95 millimeters of mercury. And it tells you that you can ignore the partial pressure of ethanol. Why is that important? So thinking about what we know from chapter 10, right? All liquids are able to be somewhat vaporized at ambient temperatures, right? Between water and ethanol, which one would be more readily vaporized? AKA, which one is more volatile?
Ethanol.
Ethanol, yeah. So technically, it's not a great assumption that we're saying that the partial pressure of ethanol is negligible, but it's whatever, right? I've tried to simplify the problem for you guys a little bit. But if we were really doing a problem like this, we would want to take into consideration the partial pressure of ethanol as well at this temperature. Is everybody comfortable with why water is a part of this reaction?
Can you repeat it?
Yeah, I'm asking
Tell us why.
Yeah, I think this isn't super obvious, right? But just remembering when we talk about solutions, right? We're talking about a solution of glucose, what we're saying is that it's only 25% by mass glucose. The rest of that solution, what's it made of? Water, right? That's what that little AQ means. Does that make sense, guys? So, but I don't think that's obvious. I don't think it's obvious to see that that water is a part of this, right? So if you didn't see that, that's totally understandable. You guys
okay, that makes sense.
yeah, but this is why I wanted to go over it, because I think it's not super intuitive, but it is putting together a lot of what we're seeing in multiple chapters, and this kind of problem is going to be really common going into 201. So
I have a question really quick.
yes, go ahead, Harrison.
So my variant of this problem, I was given
peroxide.
Yeah. So what was given was the pressure of the total pressure.
Yeah.
So then you use the total pressure equals nRT over V to find it.
The total pressure equals nR. No, because here you're going to be using Dalton's law of partial pressures.
Oh, okay.
So I'll get into it. Yeah. So there's multiple variations of this question. The one that you and Harrison had was the hydrogen peroxide decomposition, but the concept and the way that you solve it is the same. Okay, so it's just different numbers, basically. Different numbers in a different chemical reaction. I did not balance this equation either, which will be problematic for me. I believe there's a 2 here and a 2 here. Cool, that's gonna be important. Does that make sense too? So I apologize, but it would take me too long to go through both of these problems. And I'm going to make all of them available to you guys so that you guys can go through and try them all. You know what I mean?
Yeah. If I have any conceptual questions, I'll ask, but it's not a big deal.
Cool. Okay, so bleep bloop blop.
What? I'm sorry.
Go ahead. No, that's fine.
What is that number right next to the carbon in the product? It's 2 carbon, and then I don't know if that's a 0 or a 6.
2.
But, yeah.
2, 5, OH.
Okay.
Sorry. Is that cuter?
Yes.
Cool. Sorry, you guys. Handwriting. Okay, so first and foremost, one of the hardest things to hold on to in a problem this big is what the heck you're looking for, right? So that's definitely the first thing that I want you guys to try and highlight when you're solving these problems. And it looked like from looking at the few that I've graded so far that you guys did a really good job of trying to clarify for yourselves what you're solving for. So I'm looking for a volume of CO2 gas. Now, there's a really important property that I think we mentioned when we were talking about the ideal gas law, but I think bears repeating, and that is that the ideal gas law can only be used for gases. So I know that this may sound trivial, but it's super important, right? What are the gases that we have in this reaction?
Carbon dioxide?
Only carbon dioxide, right? So carbon dioxide is the only thing that we can use to put into PV equals nRT. Does that make sense, guys? So none of the information given about glucose can go in here, right? Analogous would be the hydrogen peroxide, right? So you're given a bunch of information about hydrogen peroxide, but that information can't go into PV equals nRT, right? You have to first get the moles of whatever you're starting with into moles of gas, right? Does that make sense? So let's look at how we do that. So we're given 48.25 grams of solution, right? And we're told that that solution is 25% by mass. This is, right? Is everybody comfortable with that? I didn't have to write it this way, right? I could have just used the decimal equivalent. That would have been fine. But I think this way makes it a little bit more obvious to see that the grams of solution and the grams of solution here cancel, right? And so then what you're left with is units of glucose mass, which then you need to use the molar mass of glucose. To convert to moles of glucose. And I don't remember what the molar mass of glucose is off the top of my head, so let me look at, I'm going to cheat and look at somebody's work.
(180.156 grams per mole).
Thank you. Perfect. Awesome. Thank you for that, Harrison.
No problem.
I think that was probably much easier than what I was trying to do, which is the lazy way. Cool. So that gets me into moles of glucose, right? But again, moles of glucose cannot go in here, right? The only moles that can go in there are moles of gas, right? So we need to convert these moles of glucose into moles of CO2, right? So for every 1 mole of glucose, I have 2 moles of CO2. Sorry, it's getting a little ugly there towards the end. Is everybody picking up what I'm laying down here?
Yeah.
Cool.
Yeah.
So, what do we get for NCO2?
.13 moles.
Anybody else want to chime in on that one?
Would you use the sig figs from like the grams?
So
of
you've
the
got
solution.
4 here and 3 here, right?
Right, so you would use 3.
So you would need 3 here. So
This one's
point-
4.
3, 4.
Perfect. Everybody all right with that? Cool. So, the other thing that's important when you're looking at PV equals nRT is that you're looking at the partial pressure related to carbon dioxide and the partial volume related to carbon dioxide as well as the number of moles of carbon dioxide, and we assume generally that the temperature is at thermal equilibrium, so whatever temperature this whole thing is, that's the temperature of the whole system, right? But this is another important key to making sure that you solve this problem, right? So I would say this part is probably the trickier part because it involves the solution chemistry as well. Sorry, guys. But then the next thing that we need to do is solve for the partial pressure of carbon dioxide, right? So we know that P tot is going to be equal to PCO2 plus PH2O, right? You guys with me there?
Yep.
So then what is the partial pressure of carbon dioxide? So,
Could you subtract the partial pressure of water from the total?
exactly. Yes. So you're going to take the total, subtract the partial pressure of water, right? And then we're going to want it in ATMs, right? So that we can use our R value that we know.
Got 1.008.
You guys okay with that?
Yeah.
Cool. All right, I'm going to switch pages. I ran out of room. So now I can solve for the volume of carbon dioxide, which is going to be equal to NCO2 times R times T divided by the partial pressure of carbon dioxide, right? 0.134. And then the temperature was 26.2, was that right?
Doesn't it need to be in Kelvin?
Yeah, 26.5.
It's 299.65 in Kelvin.
Oops. So one of the things that I wanted to emphasize to you guys when you're going from degrees Celsius to Kelvin is that this is an addition, right? So 273.2 Kelvin plus 26.5 degrees Celsius is what you need to do, right? So does everybody see how when you do this addition, you end up with 4 sig figs here? It doesn't matter for this particular problem, but it was something that I saw was a really common way that people got sig figs wrong on other problems.
Yeah.
Just so you guys remember the decimal place is what rules the day there. Cool. And then the partial pressure we said was 1.008 atmospheres.
$3.27.
You guys cool with that? Questions?
Would it be in liters?
Yes. So what do you guys think?
It's not really that hard. It's just there's a lot of parts to it.
And that's going to be, again, so this is what I'm trying to get you guys ready for, is that this last test is a lot of that, right? There's going to be way less problems, but way more moving parts, right? So especially compared to the last exam was very conceptually driven. There's definitely some conceptual material for sure in chapter 10, but a lot of the chapter 5 and chapter 13 stuff is very calculation driven, and the problems tend to get a little more complex. So that being said, I've noticed that some of my students have been struggling with time, in terms of the time limits. My main motivation for trying to limit you guys on time was to prevent people from cheating, but I feel pretty confident that you guys are really working hard and not cheating, so I think I'm gonna loosen those up, basically. So I think probably from now on the exams I'll do 3 hours, and then quizzes I'll do 1 hour and 15, because I know that sometimes your fucking internet is just not working, right? Like things just happen, you know what I mean? So I want to try